I need to find the current I in this branch having 50 ohms resistance using source transformation technique. So I will assume in this video that the theory of source transformation technique and current divider rule is known to the viewer. So I will start like that. I actually did this video long ago, but I am redoing it because of some audio issue, and so yeah, I will do that. So I will start doing it. First, if we look here, uh, these two, this is a current source and a resistance in parallel, so it can be converted into a voltage source using source conversion technique. So the voltage source will be, of course, V will be I times R. So I here is 1 ohms and R here is 40 ohms. So the circuit will become like this. The polarity of the voltage source will be like, so the current was going upwards, so the polarity of the voltage source will be such that the current goes upwards. So it will be like that. So the voltage source will be 40 volt and the resistance will stay as it is. It will come in series 40 ohms. So this is the conversion here. This part is the converted part, and then the 40 volt resistance that was there stays there as it was, and the 40 ohms other one which is here stays there, and then the 20 ohms, then the 50 ohms. So 20 here, 50 here. I am just writing them. Now if I notice again, these two voltage sources are coming in series, so they can be added, and these two resistances are also in series, so they can be added as well. The voltage sources will be added because their polarity is in the same direction, so they will be added, otherwise they will be subtracted. So these two added will be 80 volts, and these two resistance will be 480 ohms again. So 80 volts and 80 ohms, and they will be like that. So 80 ohms here, 80 volts here, and then the 20 ohms is there, and the 50 ohms, the one, this current we are interested in, we need to find out. Now again we can see that these two are, we have to use source transformation as much as possible. So here we can see that these two are a voltage source and a resistance in series, so I can convert it into a current source and a resistance in parallel basically. So the current will be upwards here as it was there. So then, and the I will be 80 voltage over 80 resistance, so it will be 1 amps. The resistance will be 80 ohms here, and it will come in parallel. 20 ohms resistance stays there. So basically this is up to here is the transformation, and then it is 50 ohms there. So that's like that. Now what we can do, we cannot change this one here. From here we cannot change anything. Up to there we can do whatever we like. So what we can do here, we can see that these two resistances are in parallel, so we will find the equivalent resistance. So here we have 1 ampere, sorry, the current, and the parallel of 80 and 20, and this will be 50 ohms here. So the parallel of 80 and 20 will be 80 times 20 and 80 plus 20. So basically that's 80 times 20 over 100, so that will be just 16 ohms. So 16 ohms here, and then 1 ampere is the current there. So what now I can do, I can actually again convert this part. This is a current source and a parallel resistance, so I can again convert it into a voltage source and a series resistance, and I will do that. So again the voltage polarity will be like that, and 16 times 1 will be the voltage, 16 volts, and the resistance will be 16 ohms. It will come in series, so this is the converted part. This is 16 ohms, and this is the resistance that we are interested in. This is our this is what we have got finally, and we cannot change anymore because this current we need to find, and this current hasn't been affected yet because we have changed only part which is to the left here. So what happens now is the current I we need to find. So current I will be voltage V over R, combination of R. So this will be 16 volts here, and 16 plus 50 there. So the current we get is 16 over 66 amps. That is the current we are interested in. We have used source transformation for this particular problem. When it said use source transformation, we have to keep using source transformation as much as possible. We didn't need anything else except the Ohm's law in the end, but otherwise we didn't need any other theorem or technique to solve this one.